So my mistake is that I'm trying to declare a function, although it's virtual. It's not completely abstract because the compiler is expecting that I will be implementing it somewhere else like this, and providing its implementation. So that's what the compiler wants me to do with this type of syntax. However, in C++, to keep it virtual, I need to make it pure virtual, which means equals 0. So this way, this will compile fine. All right. So anyway, so problem fixed. So this is a sample that we have that essentially demonstrates an abstract method with pure virtual function. This is what makes it pure virtual function, which is an equivalent to abstract keyword in Java. And so we have an employee, so we need to be able to actually print the ID, right? So the ID equals employee print ID, and everything should work. So we're just going to do this trivial test over here. Sorry, just clicking wrong. Okay. Let me run this and see what's going on. So I don't have a function that returns anything, so this is my mistake. So instead of saying employee print ID and send it to a stream output, of course what I need to do is use this print statement, right, and then call employee print, and then I can say std cout and display this, right? So this is what I really need to do with the type of class design that I have right now. So finally, if I build this, this should be fine. And so now if I run it, right, just debug it, so that makes it print this silly ID. But this entire discussion has started as we said that there could not be virtual data attributes inside the class. So let's quickly test that, right? So if I attempted to say virtual int MID, right, and tried building that by mistake, or maybe I tried to express something, it says MID declared as virtual field. So that's all the compiler tells me. Essentially, cannot have virtual fields or data attributes. That's all. This is contradictory with an idea of memory allocation, and so nothing can be virtual over here. So that's the idea behind that. Just be aware of it. However, again, I try to tell you that although the class person is abstract and cannot be instantiated, and we made it all artificial and stuff like that because it has this pure virtual function, which is an equivalent of abstract in Java. At the same time, it can have a constructor, and of course the constructor is invoked from the derived class, from the employee class that derives from the person class. So that's still completely okay and very practical, right? So abstract classes can have data members, and that's okay. All right, so I guess this is almost everything that we can do today. Let's just see what else is left in this presentation. We also can talk about the interfaces, but we already discussed the interfaces before, and I think our set of samples for CIS 260 does implement samples for the interfaces.